All right, so let's try practice number 3. It says create a distance time graph to represent the motion of the following objects. Calculate the object's average speed and then determine the distance traveled by the object after 10 seconds. So we've got quite a bit of things to do here. Our first job is to graph this. So I'm going to, well, I took a picture of it on my phone, but for the here, I'm going to make a graph of this, and I'm going to use this graph paper, but basically, I don't know if I can write on the side. I don't think I can. Only on the paper. Okay. So our graph is, if we look back at it, and I'm not going to have it up here just because I can't in this screen, but our table goes from time 0 to time of 10 seconds. So our time only goes up to 10 seconds. And on our graph, what we're going to do is we're going to always make sure when you're drawing a graph is that this is not going to be exact because I'm drawing, I guess I could use a ruler on my screen. But our x-axis, which is this, and our y is up here, our x-axis is always going to be time. And in this case, it's time in seconds. So just to go back so that you remember and I'm not just making this up, time in seconds is right there, and it goes from 0 to 10. Then our distance traveled goes from 0 to, we don't know, but at least goes to 40, okay? And something that you may have learned in the past, or you should have, we could probably predict this, and I think that's what they want us to do. We could predict what this is going to be. And why is because we notice there's a pattern here. Between 0 and 2 seconds, it goes up by 10. 10 to 20 is 10. 20 to 30 is 10. 30 to 40 is 10. So if we're following the same pattern, it should go up by 10. So if we started at, if we're at 8 seconds at 40, we should be here at 50. Okay? So drawing our graph, we're going to be going up to 50 meters. And that's going to be on our y-axis. Okay, so going back to that. So when we draw this, we're going to need to draw in our scale. So right here is going to be 0. I'm going to do every one square is going to equal 1 second. Oops. And it's really important when you're doing a graph that you are keeping your units the same amount. Like you can't go 2 here and then 10 here, and then you need to have the same amount of units in between each. So each block on your graph represents a certain amount. Okay, as long as you're keeping it the same, you can do it however you want. So on the side there, I'm going to use each block as 1 second. So every one in between, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It could go up to 11. And then on our y-axis, that's going to be our distance. So it's important that we write that on there. Distance. And our distance is measured in meters, so we need to write that in there. Now, this is going to obviously be 0, but we need to go all the way up to 50. So if I wanted to use every block as 1, we wouldn't have enough space. So something that you might want to do here is maybe go up by, if I did 2s, then that would be too much because that'd be 25 spots. So I'm going to try going up by 5s. So whatever your scale is, you create that scale, but you need to abide by it. So if that's 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and that's really as high as we need to go. But if you wanted to continue, you can. I'm only doing this because I don't like just stopping there. All right, so that is our units. So we've made our graph, or we've made our axis, and we're ready to graph our information. So going back to our data, basically, you're going to find the space on the x-axis is this one, and y is this one. And I think I'm on the wrong diagram. Definitely. X-axis, y-axis. All right? So how we're going to do this, our first point is going to be at x0, y0. Well, that's pretty easy because it's just going to be right in the corner. And I don't know why this like blurs every time I do this, but it's going to go there. Now our next point is at 2 on the x-axis and 10 on the y. So 2 on the x-axis is here, and 10 on the y is here. All right. Next one is 4 and 20. 4 and 20. 6 and 30. 6 and 30. So hopefully you can see that I'm going 6 on the x, 30 on the y, and then I'm meeting in the middle. All right, that's how I'm doing this. I know you can't see me sort of tracing because that doesn't show up. On our time at 8, it's at 40 meters. So our time 8 goes up to 40 meters right there. Just want to get rid of that line. And then our last one, 10 seconds, we said is at 50. So 50 meters. All right. So you can see we've graphed the information, and we figured out, I guess, the line of it. So now we've graphed our information. The next question was asking us to find the slope. So you can leave the just as dots if you would like, or you could connect the dots. I'm going to connect them the best I can. All right, so that would be the slope of the line. And then we can use 2 points, just like we did before, to figure out the slope. So I'm going to write that here. The slope of the line is going to be equal to our rise over our run. And then we need to do 2 points. We do y2 minus y1 divided by x2 minus x1. All right. So in this case, our y2, I'm just picking a random point. Again, you could choose any of these because they all cross over very cleanly. So I'm going to pick this point and this point. All right, you can pick any of them. It should be the same because we've got a constant speed here. So for x2, I'm going to pick, this is going to be my y2, x2. I guess I don't want to write it that way. This is my second point. And this is my first point. Okay, so our second point, our y, is going to be at 40. And our x is going to be at 8. Our second point, our 1, is going to be, the y is at 10. And the x is at 2. Okay, so that's where I got those. So I would just calculate this out now. 40 minus 10 will give me 30. And 8 minus 2 will give me 6. All right. And then I'm going to calculate this. So 30 divided by 6 should give me I believe. All right, so that is our slope of this line. And remember, something really important is that we need to have units. So again, I should have had units here. This is going to be meters per second. All right. That is how we draw a graph of it and how we find the slope of the line from our graph. All right. The last question here was determine the distance traveled. Well, we already did that. We found the pattern to figure out that it was 50. All right, so speed versus time graphs. Speed time graphs may be used to confirm that an object is traveling in a uniform motion. So these are a bit different. We were doing distance time graphs where we had distance on the side and time here. Now we have speed over time. Okay, so that's like meters per second divided by seconds, right? And that's basically going to figure out something that I'm not sure if they talk about what that is in this. They don't. But our speed versus time graphs, if we find the slope of these lines, it's going to give us something called acceleration, which I believe is in the next PowerPoint or the next topic 3, but we will just focus on this. So our job here is looking at these graphs. We can tell whether something, I guess, is going at a constant speed, is speeding up, slowing down, that sort of stuff. So in this case, if the line is straight on these types of graphs, that means that they are going at a constant speed. Right, because they're keeping the same speed. They're going 10 meters per second over 3 seconds or however long. So flat lines on this are a good thing. It means that they're constant speed. The second one here, as time goes on, the speed is increasing. So we would say these people are speeding up. And then the last one, speed of meters per second over time. We've got 2 lines here where one is part of the graph. If I can. One part is speeding up. And then the other part is constant. So this might be more realistic to you driving your car where you're at a stoplight, it turns green, you start speeding up. Once you get closer to the speed limit, or let's hope, you start to level off and keep a constant speed. All right, so that's more realistic to obviously what would happen in real life. Here's some practice problems. It says examine the graph to the left and then describe the motion of the bus from these points. So from O to A, that's our very first line here. We need to describe, and maybe I'm just going to do that right on here on the graph. So this line, because they're going up, they would be speeding up. A to B would definitely be a constant, because remember, flat lines are constant. From B to C, we haven't seen this one yet, but to go from B to C, this means you're slowing down. Because your speed over time is going down. You have less speed, so that's a slowing down. Here, because it's at 0, you're actually stopped. And then you're speeding up again here. And then here we're going constant again. Okay, so that's how we are expected to sort of analyze a graph, and that's something that you are supposed to know. But once you get the hang of it, I don't think it's too difficult. It's just sometimes confusing to people to remember the difference between a speed versus time graph and a distance versus time, because a flat line on a distance time graph means you're stopped, and a flat line here means you're going constant. So you just got to remember the difference of those two, and once you do, you got it.